Thank you for joining this lesson. We're going to revise Vector 2, a question which was in Kcse 2022 Mathematics, Paper 2. Number 14, the question says that the position vectors of points P, Q, and R are as shown respectively. Show that P, Q, and R are collinear points. Remember to subscribe and to share this link with your friends. So what we're going to do here is to show that 3 points are collinear. And for us to show that points are collinear, we just prove that 2 vectors are parallel and that 1 point is common. Therefore, we prove that any two vectors are parallel and that they share a common point. They have a common point. Therefore, this is now what we call collinearity. The condition to satisfy that 2 or 3 points are collinear. Show that 2 vectors are parallel and that they share a common point. So for us to show that 2 points or 2 vectors are parallel, then they must have a constant, or rather, for 2 vectors to be parallel, they should have a common scalar. Or one must be a scale multiple of the other. Let's get to the working of this question. We have OP, OQ, and OR. We can consider vectors like PR. And for us to find vector PR, then we need to pick R minus P, or rather OR minus OP, which takes us to, when we take OR, we shall have 8, 3, and 4. I'm just picking the constants and leaving the unit vectors. Then P, which is 6, 2, and 3. And this will give us 2, 1, and 1. So that is vector PR. We can look at vector PQ again, such that we will take OQ and we less OP. And this will be 12, negative 5, and 6. 12, negative 5, and 6. So there is something we should remind ourselves here, that in the vector OR, we have 8 as we have lifted it. Then this one is a negative 3 and not 3. So this is a negative 3, like that. And again, on OP, this one is negative 2. So it should be a negative. The negative must be. So every number must be accompanied with its sign, such that negative 3 minus negative 2 becomes negative 3 plus 2, which is negative 1, like that. Therefore, on this other side now, we are taking 5 together with the sign behind it, such that again we will subtract 6, negative 2, and 3. And this will give us 6. And this will give us negative 3, while this one gives us 3. So we have vector PR and PQ. So we can look at how the two vectors are related. If we say PQ equals to a constant times PR, then we can look at what constant is this, such that 6, negative 3, 3 equals to a certain constant times PR, which is 2, negative 1, 1. And in this case, if you find K is going to be 6 equals to 2K, such that K is 3. Again, when we relate this, -3 equals to -1k, whereby k is equal to 3. And finally, we have 3 equals to 1k, according to this other dimension here. Therefore, k again becomes 3. So we have proven using all the 3 dimensions that the constant is 3. So this means vector PQ equals to 3 multiplied by vector PR. This means because there is a vector or a scalar multiplier here, which multiplies one vector so that you may get the other, then PQ is parallel to PR, and P is a common point. P is a common point. Then we say the 3 points are collinear. The 3 points are collinear. Therefore, P, Q, and R are collinear points. Thank you for following. Subscribe and share the link.